What is going on, pre-cal? Hope you're having an amazing day today. Joining us live from room 324, Colleen High School. Please welcome your teacher. That's pretty sad when you have to give your own intros, isn't it? No wonder. Today we're going to be talking about exponential equations. To solve exponentials, there's really two basic methods. Number one is the easy one. Convert it to the common base and solve, and we've done that one before. Just to remind you of what that looks like, look at number one. 3 to the x plus 1. Well, you can rewrite that and use 3 to the x plus 1, and instead of 81, just call that 3 to the 4th. That's method 1. And then solve it, so x plus 1 equals 4, x equals 3. Method 2 for solving exponential equations is to use bases, like logarithms. And here's how we're going to do it. Rewrite the equation with one term on each side. So number 2 here, 2x to the 5th equals 5. That's one term on each side. Take the common or the natural log. Now the common log is just log with a base of 10. The natural log is ln, base of e, on both sides of the equation and rewrite it using the properties of logarithms. So it's a pretty neat little tool. Let me show you how it works on number 2. We've got 2 to the x equals 5. So I'm going to rewrite that, and I just really like the natural log, so I'm going to use the natural log. The natural log of 2 to the x equals the natural log of 5. Fantastic. And what this does is unlocks that exponent so that I can drop it down. Remember, algebra says anything I do to one side and the other is okay, as long as I do it to both sides. So what that lets me do is write x natural log of 2 equals the natural log of 5. And then divide it out, x equals the natural log of 5 over 2. Oh, wow, excuse me, the natural log of 2. Can't forget that. And then to find out what that is, I just type natural log of 5 divided by natural log of 2. 2.322 if you round up. 2.322. So it's a neat little process, and then solve the resulting equation. That was that step. It's a neat little process. There's not really much that can go wrong with these, but it's a second option. Instead of using common bases, we can use logarithms. And it kind of unlocks the whole process for us. Makes it really cool. So problem number 3. First, I need to try and simplify as much as possible. One term on each side. See, this is a problem because I've got 2 terms over here. I've got 8 and then I've got 3 to the x. So I'm going to divide 8 and move it over. And I will have, let me zoom in here so you can just see this problem. And I'll have 3 to the x equals 5/8, which is just a number. So I used natural log last time. Let me use the regular log this time because, well, why not? Log both sides, and that lets you unlock this exponent. Call it x log 3 equals log of 5/8. So x is going to be divided out. You've got log of 5/8 over log of 3. Doesn't matter if you use the natural log or the regular log. It's going to end up giving you the same number here. Let me show you here. The log of 5 divided by 8 divided by the log of 3. And the ratio is going to stay the same. It doesn't matter if you use the regular log or if you use the natural log. Negative 0.428 if we round up. So x equals negative 0.428. Pretty simple, right? So really the only thing they can do is make it more complicated. And I don't really see the problem with that. Number 4, one term on each side. See, I've got 500 e to the power here. I need to get rid of that 500. So let's go ahead and move that over. Divide by 500. You get e to the 0.3x equals 6 over 5. Now, since I have e here, I'm going to use the natural log because that's going to simplify my life a lot. I've got e, so I might as well use the natural log and just simplify it. 0.3x equals the natural log of 6 over 5. Divide by 0.3. Natural log of 6 over 5 divided by 0.3. And let me punch that in real quick. Natural log 6 over 5 divided by 0.3. And I get 0.608. Pretty easy subject, yeah? Number 5, last one here. It says 5 to the power of x minus 2, 3 to the power of 3x plus 2. Well, there's already one term on each side, so I'm going to use the natural log again. I like using the natural log. Why not? I'm going to go ahead and natural log both sides and bring down the x minus 2, so I'll have x minus 2 times the natural log of 5 equals 3x plus 2 times the natural log of 3. Now this one is a little bit more interesting because I can't just get x by itself here because they're kind of all over the place. So what I'm going to do is I'm going to distribute this natural log 5 and this natural log 3 into these guys. So we'll have x ln 5 minus 2 ln 5 equals 3x ln 3 plus 2 ln 3. Excuse me. All right. Now, you may ask, well, what does that do for me? Well, what I can do now is I can get this 3x over here, and I can get this 2 away from that. In other words, get all your x values to one side, x ln 5 minus 3x ln 3, and get everything else to the other side. So that'll be 2 ln 3 plus 2 ln 5. And then using your properties for logarithms, I can simplify that even more. See, I can factor out an x out of this and leave this as ln 5 minus 3 ln 3 is equal to, and if I were to combine this and rewrite it, this is, and I should have done the same over here, so I'm actually going to do that right now. The natural log of 3 cubed, I'm going to take this 3 up here. This is the natural log of 3 squared plus the natural log of 5 squared. And you can simplify that down to being x times the natural log of 5 minus 9, or 5 divided by 9, if you'll excuse that. 5 divided by 9 equals the natural log of 9 times 25, which is 225. And then divide it over. X is equal to, divide your natural log, the natural log of 225 divided by the natural log of 5 over 9. And that is going to be natural log 225 divided by the natural log of 5 divided by 9. And that is going to be negative 3.212. So a quick little video. It's a neat little process, and it kind of unlocks a lot of possibilities for solving exponentials. Have a great one.